All right, let's just jump right in. Area, surface area, and volume. For a lot of people, this is the chapter that just causes a massive headache, right? It feels like it's just a bunch of formulas you have to memorize. Well, I promise. In the next few minutes, we are going to break this whole thing down and make it actually make sense. Totally intuitive. And listen, if you've ever found this stuff tough, you are so not alone. I love this quote from a teacher who called it the black sheep of the math family. And it kind of makes sense, right? It's often that one topic that gets crammed in at the end of the year and everyone's left scratching their heads. But you know what? It really doesn't have to be like that at all. We're going to tackle this together, piece by piece. We'll start with the basics and build our way up. And I'm telling you, by the end of this, you're going to see how all these ideas connect to real-world stuff, from tiling your floor to designing a massive skyscraper. Okay, so first things first. Before we can build a skyscraper, we need a solid foundation, right? So we're going to start in the flat, two-dimensional world. And the two big ideas here are area and perimeter. It is so important to get the difference between these two.
So, what exactly is area? Well, put simply, it's just the amount of flat space a shape takes up. The best way to think about it is tiling a floor. If you're going to cover your kitchen floor with tiles, the total number of tiles you need, yep, that's the area. And we always measure it in square units, like square feet or square meters.
Now, check out these two shapes on the screen. On the left, we've got this nice, compact 4x4 square. And on the right, a long, skinny 2x8 rectangle. They look totally different, don't they? But, and here's the cool part, if you actually count up all those little squares inside each one, you'll find they both have exactly 16 square units, the same amount of space inside.
Okay, so we've established they have the exact same area. But what about the perimeter? Now remember, perimeter isn't the space inside. It's the distance around the outside, like putting up a fence. So take a second. Do you think these two shapes with the same area have the same perimeter?
And here's the big reveal. Nope. As you can see, even though the area is 16 for both, the perimeters are way different. The square has a perimeter of 16 units, but that long rectangle, its perimeter is 20. And this shows the difference perfectly. Area is the stuff inside, measured in square units. Perimeter is the path around, measured in plain old linear units.
This leads me to a huge, super common mistake people make. They try to compare area and perimeter, saying one is bigger than the other. You just can't do it. It's literally like comparing apples and oranges. One measures flat space, the other measures length. They're two completely different things.
All right, awesome. We've got 2D down, so let's level up and add a third dimension. We're moving into 3D space now, and the first thing we're going to look at is the total area on the outside of an object. This is called its surface area. Honestly, the best way to get your head around surface area is to think about wrapping a present, right? The total amount of wrapping paper you need to cover every single side of that box. The top, the bottom, all four sides, that's it. That's the surface area.
So, how in the world do we calculate that? Well, the secret lies in something called a net. Just imagine you could take a pair of scissors to that box, cut along some edges, and unfold it so it lays completely flat. That flat pattern you see here, that's the net. And look, it's just a bunch of simple 2D rectangles that we already know how to find the area of. So the whole process is actually way simpler than it sounds. Step 1, you picture that unfolded net. Step 2, you find the area of each one of those flat faces, which is just a simple length times width calculation. And then step 3, you just add them all up. Boom, that's your total surface area. It's really just a few simple area problems all rolled into one. Okay. So we've covered the outside of a 3D shape with surface area. Now it's time to dive inside and figure out what's going on in there. It's time to talk about volume. So if surface area was the wrapping paper, then volume is all about how much stuff you can actually pack inside the box. It's the total amount of 3D space an object fills up. And instead of using square units, now we're talking about cubic units, like cubic inches or cubic centimeters. To really get why the formula for volume works, imagine you're filling that box with tiny little 1-centimeter sugar cubes. The very first layer of cubes would cover the entire bottom of the box, right? And the number of cubes in that single layer is just the length times the width, which, hey, that's just the area of the base. Okay, so you've got your first layer down. Now what do? You just keep stacking more layers of cubes, one on top of the other, until the box is totally full. And how many layers do you need? Well, you need a height number of layers. And that, right there, is why the formula is length times width times height. It's the area of the base times how many layers high you stack it.
Now here is a major pro tip, especially for those tricky word problems. Listen up. If a question ever says you're going to melt down a block of chocolate and pour it into a new mold, remember this key principle. The amount of chocolate itself doesn't change. That means its volume stays exactly the same. But the new shape? It will almost definitely have a different surface area.
Okay, you've got the big ideas down. You understand the difference. Now, let's do a quick lightning round of pro tips to help you avoid the most common traps that students fall into on tests and homework. You're going to want to pay attention to these.
Tip number 1, and this is probably the biggest one. Check your units. Seriously, this is where so many easy points are lost. Before you do any math, any calculating at all, make sure every single measurement is in the same unit. If one is in meters and another is in centimeters, you have to convert one of them first. And when you get your final answer, please remember to write the correct unit. Squared for area, cubes for volume.
Struggling with a word problem and not sure if it's asking for area or volume? Use this as your guide. Just ask yourself one question. Am I covering something or filling something? If the problem is about painting a wall, wrapping a gift, or making a tent out of cloth, you're covering a surface. That's surface area. But if you're filling a swimming pool or figuring out how much soda is in a can, you're filling a space, and that is volume.
And of course, what's a math chapter without some formulas, right? So here it is, your ultimate cheat sheet. It's got all the key formulas for the big shapes you're going to run into. Cubes, cylinders, spheres, the whole gang. Go ahead, pause, and take a screenshot of this. It's going to be a lifesaver when you're studying.
All right, let's wrap this up with one final brain teaser to get you thinking. Imagine an architect is designing a giant glass skyscraper. Which do you think they care more about, its surface area or its volume? And why? I mean, think about it. One of them determines how much that glass skin is going to cost and how much it'll cost to heat and cool the building. The other determines how much office space they can actually rent out to make money. So which is more important? Thinking through real-world problems like this is how you go from just knowing the formulas to really truly understanding the concepts.